Prior to the write-up, you need to be quite clear about these items here on this one slide. You need to have a clear research question, and that needs to be presented. You also need to include the null and alternative hypotheses to that particular research question. You need to identify the dependent variables and the independent variables, or if you're using groups for tested means. You want to always identify the sample size or group sizes. You want to show that if group A is, say, 75 participants and group B is 110 participants, you want to identify that in your paper for your reader. You want to identify the test statistic applied to answer the research question or research questions. And when we refer to test statistic, that is the statistical test which you're using to answer that particular research question. When you list your research questions out, you want, if you're going to be using a simple linear regression to see if there's an association between A and B, then you want to identify that in your paper. If you're comparing the heart rates of 3 different groups, then you'll be running an ANOVA, and you want to identify that you'll be applying a one-way ANOVA to these 3 groups to monitor to determine whether or not the outcome variable of heart rate varies from group to group. These last 3 are a bit of a challenge for many people. The effect size, the level of precision, and the power. Now, here at the ASC, and I'm sure Kim can put up the links to our videos, or tutorial videos, but we have videos on power analysis, and that's where effect size, level of precision, and power come into play. Effect size is really, in its very simplistic form, it's the size of the difference that you've predetermined to say whether or not there is a statistically significant result or not a significant result. It's a proportion of the size of the difference, and effect sizes are thought of coming in small, medium, and large. The level of precision, the alpha, that relates directly to the p-value and also relates back to your confidence interval. If you're using a 95% confidence interval, that means that you have 5% that you're not confident in. That level of precision is that 5%. So that's where the p, we've all seen p equals, p based on 0.05. So that is you have your confidence interval of 95%, and then you have essentially your unconfident area, which is 0.05. Power, 1 minus beta. Power is the power to detect a statistically significant result. Most times for our practice, we use 0.80 as power. That 0.80, when we subtract it from 100%, we're left with 0.20. 0.20 is our false negative rate. So with alpha, we've got a false positive rate of 0.05, or a false positive threshold, and then power at when we look at beta at 0.20, that's our false negative threshold. So, those being said, what are the components that need to be included in the write-up? Because on the previous slide were those things that you have to, essentially it's a preamble to your write-up. You have to include those so that your reader understands what are essentially the ingredients for your statistical analysis. But once you run your statistical analysis in SPSS, you want to write up the results. So here's a list of components. Now, this is not an exhaustive list. However, it gives you an idea of what are the items that you need to include. Now, for those of you who are still doing coursework, your instructors may or may not want this much information. They're just looking to see whether or not you understand the statistical test, and they want you to present your findings of your data analysis.